Hello, my nerdy Nawg-Dawgs. Today in class, we were talking about fractions of a set. And so, for example, we said, well, if we had something like 2/3 of these total hearts, right? So if you notice, I counted out 12 hearts, 2, 4, 6, 8, 10, 12 hearts. And maybe I promised my kid that I would give her some of them. So I've got 2/3 of the total 12. So in this case, we're talking about a set of 12, right? And therefore, I want to find a portion, which a fraction is always less than one whole, right? A portion of the total 12. And so there's a couple ways to think about this. When we look at the denominator, we know that what we're being asked is to put this 12, this bunch of 12, into 3 groups. That's what the denominator means, a group of 3. The numerator is telling me how many of those groups. Okay, so I'm going to get 2 out of the 3 groups. So keep that in mind as we go, okay? So I'm trying to sort these 12 hearts into 3 groups because 2 out of those 3 groups is going home with me today. Oh, love. So 2/3 of the 12. Now here's another thing we talked about, that of, and I'm going to continue using that guttural sound when I say it so that it makes your brain connect to it, right? Brain-based learning. So 2/3 of, we also learned that when we say of, we're talking about a portion of the total. The operation we will use is multiplication. That of means multiply because we're talking about a portion of the total. Now, another thing we learned about today was the operations for multiplying fractions, or today multiplying a fractional amount of a whole, right? So the operation is numerator times numerator over denominator times denominator. And then you have to simplify the answer. It's the easiest of fraction operations. You don't have to find like fractions. You don't need equivalent fractions. You just multiply. A numerator times numerator over denominator times denominator. Oh, there's no denominator. We're talking about a whole number here, people. So what did we do in class? I showed you a magic trick. Ready? Hocus pocus shazam! You put a whole number over a 1 as the denominator, and it doesn't change the fact that it's a whole number. Math magic is what that is, people. Math magic. So why is that? Because if we go back to our holy grail of fractions, we know that this fraction bar means divide. So what is 12 divided by 1? Well, it's always going to equal 12. 12 divided by 1 is 12. So it doesn't change the fact that that's a whole number. What it has changed is it's made it into a fractional unit so that I can solve math using it. So keep this in mind. So 12 over 1 is always going to equal 12. It's going to remain itself. Same like 8 over 1 is always going to equal 8. Whole number 8, whole number 12. Okay? Do not confuse this with 12 over 12. That will always equal just one whole number. Why? Because 12 divided by 12 equals 1. 8 divided by 8 equals 1. So this is equivalent to 1 whole. This is equivalent to 12 wholes or 8 wholes, right? So it doesn't change the fact that it's a whole number. Putting it over 1 and giving it 1 as a denominator, it keeps the integrity. It still remains a whole number. It just puts it into fractional units or fraction terms so that I can solve for it. So how do I solve for a fraction? Well, numerator times numerator, so 12 times 2 equals 24. Over denominator times denominator, 3 times 1 gives me 3. Now I have an improper fraction, right? That improper guy, he can never show up to my party, right? We don't accept improper guests shouting at the opera and not drinking their tea with their pinky up. He has to be simplified to be in final answer. So 24 divided by 3 would give me 8. 3 goes into 24 8 times. So what does this mean exactly? This means that I'm taking that 12, I'm going to divide it into 3 groups. And what I'm taking home with me today is 8. So let's make sense of that. So dividing into 3 groups. Now here's another math trick. I know that 12 divided by the 3 groups is going to give me 4. For what? That would mean 4 hearts in each group. So each group, so I've got 3 groups. Each group has 4 hearts in it. And this is what I'm taking home. This is what I'm taking home. 2 groups out of the 3 groups total I'm taking home. How many is that? That is 8 total. Okay? Fractions of a set. That is what is happening. That is what you are doing. So let's just do the math of it. The math of it. So we remain efficient and we think of ourselves as being efficient. There goes my lights. Everybody dance. Oh my gosh. Okay. And now what if I said I need 1/3 of 9? This might actually make more sense because of how our numbers work out. Or what if I said I need 2/4 of the 16 total? Well, let's just do the math of that. That means I need to separate this 9 into 3 groups, and I'm going to get 1 of the groups of 3. This also means I get to multiply. And 1, 2, 3, shazam! Now I'm just multiplying fractions. So 1 times 9 gives me 9. 3 times 1 gives me 3. Cannot leave an improper fraction. How many times will 3 fit into 9? Well, 3 times. So what does that mean? It means that I've divided this 9 into 3 groups. Each group has 3 items in it. Okay. So the math of it does get pretty simple. We also learned a math trick today. It's called cross-factoring. So this of means I'm going to multiply. I can't multiply a fraction times a whole number, but shazam, now that whole number is a fraction. Now, here's what cross-canceling is, or I'm sorry, cross-factoring is the appropriate term for it. Cross-factoring allows me, the way I think of it in my head is it allows me to simplify the problem before I multiply. And the only way in which this works is diagonally across and diagonally with those numbers. So and what we're doing is we're factoring out or simplifying or reducing in advance. So going across diagonally, do 4 and 16 have any factors in common? Meaning, can they both be divided by the same digit? Why, yes, they can. They can both be divided by 4. When I divide 4 by 4, I get 1. When I divide 16 by 4, I get 4. Now I have a new math problem. I've already simplified. And then I follow through my procedures as normal. I cannot cross factor here. We can never use 1 in factoring, right? Because it's a factor of every digit. However, 2 and 1 cannot factor out. So I go back to my original fraction rules for multiplying, and that would be numerator times numerator. 2 times 4 gives me 8. 1 times 1. Oh, but I don't leave that as my final answer. No way, because I know that 8 over 1 is the same as 8 divided by 1 is the same as 8 whole number. Aha. That is the math of fractions of a set. Good luck, nerdy Nawg-Dawgs.